My channel Rakibul Mathness. Today I'm going to be sharing with you about a topic which my schoolmate Akhil Adnan suggested. Thank you for suggesting. Sequences. Sequences are a set of numbers which follow a pattern. For example, in this sequence, which 3 is the first term, 6 is the second term, 9 is the third term, we can see to get from each term to the next term, we need to add 3. Add 3, add 3, add 3, add 3. Yeah. So this 3 is something really important. You see, 3 is the first term, right? And we notice that 3 is 3 times bigger than the number 1. 6 is 3 times bigger than the number 2. N is the term's position. So we can just write this sequence as 3n. 3 times n is the number. So if we want to find, for example, the 12th term, 3 times 12, which equals 36. If you would like to solve this manually, you would eventually find out that this is 36. Let's try finding more complex ones. For example, 3, 5, 7, 9, 11, and 13 looks pretty similar. They both, to get from the next term, you need to add 2, add 2, add 2, add 2, and add 2. Now, this 2 goes in front of n, but 2n is 2, 4, 6, 8, 10, 12. What could have we done wrong? The thing we did wrong was that we have to add 1 to n to get to our sequence. So it's 2n plus 1. So if we want to find the 12th term, 2 times 12 plus 1, which is 24, plus 1, which is 25. Okay, so if you're primary, this is all you might want to watch. But if you're secondary, I recommend you to watch the rest of this video. And if you stop watching this video now, there's worksheets in the comment section below. Now we're moving on to quadratic sequences. So we have 2, 5, 10, 17, 26, and 37. To get from 2 to 5, we need to add 3. 5 to 10, we need to add 5. 10 to 17, we need to add 7. Oh, this is not staying still. So we can't just pick random and put any of these in front of our n. So, but there's something else we notice. The differences have also something in common. That you have to add 2. This is called the second difference. Now in quadratic sequences, you put half of the second difference, which is 2, half of that, which is 1, in front of the n square. So we get 1n squared, or which is just the same as n squared. But n squared is 1, 4, 9, 16, 25, 36. And there's something we notice here. From 1 to 2, we need to add 1. 4 to 5, we need to add 1. 9 to 10, we need to add 1. 16 to 17, we need to add 1. So why not we just put a plus 1 at the end? And there we go. If we want to find, for example, the 12th term, then 12 squared, which is 144, plus 1, 145. Yeah. Here we have another sequence. 4, 13, 26, 43, 64, and 89. To get from 4 to 13, add 9, 13 to 26, add 13, and you can still do the rest. But we see something else common here. We need to add 4, add 4, add 4, add 4. So 4 is our second difference. Half of that will go in front of n squared. So 2n squared. But as we know, 2n squared is 2, 8, 18, 32, 50, and 72. So why don't we just subtract it to get what we have left? We have 2, 5, 8, 11, 14, and 17. But we have our own linear sequence here. Plus 3, plus 3, plus 3, plus 3, plus 3. Remember, that goes in front of n. So that's 3n. But we know 3n is 3, 6, 9, 12, 15, and 18. To get from 3 to 2, we need to minus 1. 6 to 5, we need to minus 1. 9 to 8, we need to minus 1. So at the end, we get 2n squared plus 3n minus 1. So we see the fourth term is 43. And let's double check that by replacing our n with 4. We get 2 times 4 squared plus 3 times 4 minus 1. 2 times 16 plus 3 times 4 minus 1. Or 32 plus 12 minus 1. Or we get 43. That is correct. Now, if you're not in grade 10, I don't recommend watching the rest of this video. But as I said before, there's still worksheets for this part at the comment section below. Geometric sequences. One thing we know here, to get from 6 to 12, we need to add 6. 12 to 24, we need to add 12. Or we could have just times 2 for all. Times 2, times 2, times 2, times 2, times 2. Interesting. These type, we have a formula. A times r power of n minus 1. A is the first term, and r is the number we keep multiplying. So here, we just replace. So what we're going to do here is just replace our a with 6. And then we replace our r with 2, because that's what we were doing, multiplying 2. So now, this is our nth term, the formula to find the nth term. So we have our fourth term, which is 48. And let's say we want to find the fourth term. We would have 6 times 2 powered to 4 minus 1. And then that simplifies to 6 times 2 cubed, or 6 times 8, which is 48. And that is correct. Think and make sure to subscribe and hit the bell icon. And bye bye.